Okay, so today we will be learning about Euler's formula and cyclic quadrilaterals. The slides are by Yolanda. Okay, Ruth, you can start us off.
Okay, so does anyone already know what a cyclic quadrilateral is? Yeah, someone said it. It's essentially a quadrilateral inside of a circle, except all the vertices have to touch the sides of the circle. So the first property is that the opposite angles are supplementary, which means that they add up to 180. So for this triangle, m plus h equals 180, and t plus a equals 180. So some practice. Who can tell me what the measurement of angle C is? Yeah, so people are saying 130. That's right. 180 minus 50 is 130. So what's the measure of angle E? Yeah, so C and E are supplementary, meaning that they also add up to 180. So you would do 180 minus 130, which is 50. And if angle B equals 180, or no, if angle B equals 80, what is the measurement of angle Q? Q is the entire angle. It's like everything in that circle that's not D is Q.
Right now, I think a lot of you guys are putting down the measure of angle D.
Yeah. So angle D is 100, and angle D plus angle Q is 360. So you'll do 360 minus 100, which is 260. So for this triangle, now we have variables involved. Find the value of x. Yeah, so a lot of people are getting it. 5x plus 13x equals 180. So then you combine the like terms and do 5 plus 13 equals 18. So then 18x will equal 180. Divide 18 on both sides until it'll be x equals 10. So next, if z equals 2x, find the measure of y. Okay, yeah, so people are getting it. So basically what, if z equals 2x, then that whole angle will be 6x. Yeah, and then so then you would do 6x plus y is equal to 180. And since we already know what x is from the last answer, it would be 60 plus y equals 180. And you subtract 60 on both sides and get 120. So next, ABCD is a cyclic quadrilateral. If angle B and angle D equals 30, then what is the measure of angle D? Oh, if angle B minus angle D equals 30, what is the measure of angle D? So this is, you have to set up multiple equations for this one. It would be it would be B minus D equals 30, then B plus D equals 180. And so for both of the equations, you add the equations together and you'll get 2B, and negative D plus D will be 0. So that will cancel out. And then 30 plus 180 equals 210. And so B would equal 105. And then you would have 105 minus D equals 30 from the original that was given in the equation. And then you subtract 105 on both sides to get D equals 75. So now there's a new property. Property 2 is called Coulomb's theorem. And this property says that the sum of the products of opposite sides are equal to the products of the diagonals. So for this triangle, it would be C times A plus K times E equals X times L. So what you did was for the opposite sides, you took the products of them and you added them, and that's the product of the diagonal sides.
Oops.
Oh, well.
We're just gonna ignore that.
Yeah.
Let's see, how do I make a rectangle? No. Okay, we're gonna pretend like we didn't see that.
Yeah, we did not see that. So find the length of D1 if D2 equals 10, B equals 5, C equals 6, and D equals 7, and A equals 5. Yeah, so you guys are getting the right answer, surprisingly. So basically what you would do with this is you would set up an equation where 5 times 6, that's A times C, 5 times 6, which is 30, plus 7 times 5, which is D and B, and that would equal 10x, which is our D1 times D2. So it would be 30 plus 35 equals 10x. And that would be 65 equals 10x. And divide 10 on both sides, and x equals 6.5.
I'm sure all of you guys got the answer that way.
Yeah, I'm sure no one looked at the answer before. So this one's a little challenging. In triangle ABC, AB equals 7, AC equals 8, and BC equals 9, and point D is on the circumscribed circle of the triangle so that AD bisects angle BAC, what is the value of AD divided by CD? And so in geometry in general, if you're confused about what they're asking you, then just draw a picture of it.
it will look something like this.
Yeah, so since since AD bisects CAB, that means that the angle CAB and DAB are equal because it's bisecting it. So that means it splits it in that angle in half. And that means that lines CD and BD are also equal. So you can just like set both CD and BD equal to X. And then after setting those equal to X, you use the theorem and you would get the opposite side is 8x plus 7x equals 9 times AD. And then you would add like terms, 15x equals 9 times AD, and divide 9 on both sides, and that would be 5/3 x equals AD. And so 5/3 equals AD divided by CD, and that's your answer.
Yes, it's because since it's a bisector, it splits the, so when you have like two angles that are sitting on a circle, their chords will be the same length. So that's why we can set them equal in length. So I can show another example. So if we have a circle and we have this one, if this one is the same length as this one, then they would be this, the chords would be the same length. So when, okay, so Audrey, you said, wouldn't that only be if CB is perpendicular to the angle bisector? Let's see. We didn't exactly teach you this yet, so yeah, basically if the angles are the same, then the chords will be the same length, because if the angles are the same, then they're intercepting arcs that are of the same degree. So that means like the angle of arc CD would be equal to the angle of arc CB, because these inscribed angles have the same angle. So that would be why their chords have the same length as well, is because these arcs have the same degree measure. Okay. Yeah, we didn't exactly teach you that, sorry, but this was a challenging problem, so it's okay. Okay, so now I think Kayan will talk a little bit about Euler's formula.
Alrighty. So right now, in like 5 minutes, find a cube or rectangular prism near you. So it can be like not perfectly a cube or a rectangular prism. As long as it's like close enough, it's good enough. Try to find something that's like showable on camera. It can be like small, but not like so small we can't see it. As long as it's like resembles that shape, it's fine. We can wait until like 10:25 for you to get it. Actually, I need to find something too. So yeah. Aryan, you stole my idea. I was gonna do my phone as a really like skinny rectangular prism. So hopefully most of you guys are back by now. So what were the scores? Oh,
Oh,
like
the
what did we
classmates?
decide on, or like what?
Oh, I think Blue Dragon won. It was like 2 more than the second place thing, and then Okapi was like 2 more than the second place thing.
If you guys don't know what those animals are, you should like totally look it up.
Yes, you should.
I mean, you kind of like don't need to do too much with your shape, so it's okay if you don't need to take off your phone case. But mine is like pretty like boxy looking already, because fun fact, I dropped my phone and like completely messed it up. So my mom made me get this really bulky case. I see some people with Rubik's cubes. Oh, you finished it? Wow. I cannot solve Rubik's cubes. I don't know how people do that. You have a thick book. Oh, okay, I see. Somebody has something that I can't tell what it is. Let's see. Pin video. Oh, it's a tissue box. Okay. And then somebody has some other box. I'm not sure what it is. A lot of people can solve Rubik's cubes. I cannot. It's like so hard. But that's cool, guys. You can't solve yours? Wasn't yours already solved?
Maybe he never mixed it up.
I just like attempt to solve it after mixing it up and just wait for like somebody I know that knows how to solve it to do it. Yeah, but those guides online, they are too time consuming and hard. Exactly. Leon understands. All right, guys. You also have a 5x5. Oh my.
Oh, wow.
I tried to solve one of those 2x2 ones and I still could not do it. Pretty sad, you know. Yes. One day you guys should like Oh, 15 minutes, that's good. Most of the boys in your class. Are you in 8th grade?
A Rubik's dodecahedron.
Oh
Wow.
my.
What are all the different Rubik's Cube shapes? Like, I know there's like cube ones. Like, I did not know there's a dodecahedron one.
My brother
Yeah,
has
that
a
one's
cube.
really hard. It's a mega mix.
Dang. You can solve it in 5? Oh my goodness. Mine are
I
just
can
like,
solve a triangle one in 30 seconds.
my Rubik's Cubes are just like probably in some random
2 by
cabinet.
2s I can also solve in 30 seconds.
10 sides. Oh my goodness. Okay. Well, the example that Yolanda thought of when she was making was a tissue box, which somebody had. I don't remember who it was. But yeah, so Kleenex, yay. So what we're gonna look at with this is just like the basic shapes in a, I'm gonna call this a cube, even though it probably isn't. So there's like edges, which are like the line sides, I guess. And then faces are like actual like 2D faces. Lines are like 1D. And then vertex is just like the pointy points. Yes, we are doing Euler's formula. All right, so what is our next slide? Let's investigate the cube. Okay, so Amy has this really cool like orange cube with some circles in them. I'm not exactly sure what it is.
You can
but it
either
looks
look
really-
at it like, you can either think of it as circles cut into it, or you could think of a cube within a cube within a cube with like a circle cut out of the side.
Oh, I see. Okay, that's cool. All right, so our friendly cube that we see a lot. What are we going to talk about? Okay, so first question. How many faces does a cube have? All right, you guys are all geniuses. There are 6 faces on a cube. Okay, then how many, which one is
Pointy
next?
part.
Is it vertices? Okay,
Yeah, vertices.
how many vertices does it have? Some people are talking about edges. How did they know? I'm going to say that next. Yep, 8 vertices. And how many edges? Oh my gosh, you guys, I think you would excel in kindergarten. I'm so proud of you. Yes, there are 12 edges. We are so good at counting. Yes, I love the enthusiasm, Brian. Yes, you guys are very awesome. I think you can agree with that. Okay, so now we're going to investigate some other shapes. Okay, so now what about a pyramid? And I think this is,
Square pyramid.
yes, a square pyramid. Okay, so guess what questions I'm going to ask again? How many faces does it have?
All
Okay.
I see is like a brief like exclamation marks, like one message of exclamation mark that fills up the chat and then it's gone because everyone is putting in the answer.
Yep, 5 faces. Okay, guess what I'm gonna say next? How many vertices does it have? Somebody said 7. I'm not so sure about that one. 5. Yes. Okay, now how many edges does it have? Oh, Colin, are you sure you belong in this class? I think you might need to go back to counting. Like, no, he fixed it. Okay. All right, you guys are surprisingly all right. Yay. Okay. So why are we doing this? Did you guys notice a pattern? Somehow, maybe. Well, for me, if I like didn't know what we're learning about, and I was some math guy a long time ago, looking at random shapes, the random polyhedra, probably would not have noticed the pattern, but some smart people in this world noticed the pattern. And basically the pattern is that when you add the number of faces to the number of vertices and then subtract the number of edges, you get the number 2. So it also works for our pyramid. 5 plus 5 is 10. 10 minus 8 is 2. Okay, is that a coincidence or no? It turns out it is not. So this is called like Euler's formula, and it says like you can rearrange it different ways. Some people in the chat said like b minus e plus f. It's like the same thing. So as long as you're subtracting the edges, adding the vertices, adding the faces, then you should be fine. So yeah, it works on both our cube and our pyramid. So we can generalize it and say it's gonna be true. So I think our next slide explains it a little. Yep. So this name looks like Euler's, but somehow it's Euler's. So Euler's polyhedron formula. This rule works for polyhedra, which are shapes that have faces formed from polygons. And polygons are closed 2D shapes with sides made from straight lines. So like not circles, but you know. Some coincidence. Yes, Euler. All right, practice. We love practicing.
I've got an example of tetrahedron right here.
Oh,
fractal
that's
thing.
true. Oh, okay, that's cool. Boiler, huh? Okay, how many faces, vertices, and edges does a tetrahedron have? And if you don't know what that is, it's the shape that's spinning endlessly on the right corner. And it just has like triangles as its faces. Also, can you like say what you're talking about? Like 4 edges, 4 vertices, 4 faces, you know? Okay, 4 faces. Our tetrahedron has 4 faces. Okay, what about vertices? Henry gave a full answer. 4, okay. How many edges? Seeing a lot of 6s. Okay, so are we right? Well, we can use Euler's formula to check our like answer basically. So if we remember, the formula that we learned was you add the faces, you add the vertices, and subtract the edges, right? And that all equals 2. So F is 4, V is 4, E is 6. Does it equal 2? Well, yes, it does. Yay. Okay, so you guys are great counters. You guys are amazing. Next question, another practice. Okay, so a soccer ball is actually not a ball anymore, guys. It's a polyhedron with 12 pentagon sides and 20 hexagon sides. If it has 90 edges, how many vertices does it have? So obviously, I don't think anybody wants to exactly sit there and count individually. So we can use our friendly Euler's formula, unless you guys just love to count, you know? Okay, so what are we missing? Well, we already have the number of sides / faces, and then we already have the number of edges. So we're just gonna like fill that in. So since there's 12 pentagon sides and 20 hexagon sides, how many sides are there? 56 sides, are you sure? No. 61 sides? I don't think so either. 31 sides? I don't think so. Okay, so now you guys got it. 32 sides, good job. Okay, and then it just says we have 90 edges. So now, solve the problem. Move all the numbers to the right and only be on the left. Some people are quite passionate about their answers, spamming. But remember, guys, excessive spamming can lead to the loss of points. Arya knows what I'm talking about. Yeah, I'm talking to you, Colin. Okay, so what is the answer? Amy's doing it for us. Yay, Amy. Oh, okay, yeah, we'll talk about the prizes in a second after we are done learning. Yep, you guys are right, 60. And yes, we will tell you the point rankings. Okay. Yay, there's a smiley face because you guys are good. All right, now I think we're switching to Amy.
Yes. So previously we said this worked for polyhedron, and a cone is not a polyhedron because it has curved sides. Its faces are not made from polygons. So does this still work? Well, let's see. How many faces does a cone have? Let's see. Do I have a cone? I do not have a cone. We have some answers. Some people are saying 2, some people are saying 1, and some people are saying undefined. Some people are giving us decimal answers. So let's count. So first we have the base, right, which is this bottom here. So that's definitely a face because it's not like a polygon face. It's just a circle, but it's still a face. And then we have this entire top part here, kind of, and that would actually be a face. So a cone technically has 2 faces because of that. So how many vertices does a cone have? Okay, looks like some people are saying 1 vertex. Some people are saying 2. But for this, it will have 1 one vertex, just that top part. So how many edges does it have? Yeah, so the edge would just be this part down here. So there would only be 1 edge. So if we counted out the parts of a cone like this, then does this satisfy Euler's formula?
Yep.
Yeah, it would satisfy if we counted out the different parts of a cone like this. Although if we're being honest, sometimes it's a little hard to classify if this top part should be a face or not, because it's like curved and it's kind of a weird shape. But if we counted it out like this, then it would satisfy Euler's formula. So what about like other shapes though? Like what are some of, do you guys know of any like weird shapes that aren't polyhedron besides a cone? Yeah, a sphere would be one of them. What are some other ones? A cylinder, yeah. Can you think of any other ones that don't use any polygons in it at all? Spherical prism.
Whoever can
Ooh.
read his mind, I will give 3 points to.
I think Brian said something interesting. So actually Brian he guessed exactly what I was thinking. So a torus is a donut shape. So like donuts are toruses because they have like one hole in the middle. And so does the torus, how many faces does a torus have? Yeah, it has one face because it's just one surface. There are no like, how many vertices does it have? Yeah, it doesn't have any vertices because it's just completely smooth. So how many edges does it have? Some people are saying it has one edge. Some people said 0 and other people said -1. Well, it has one edge because of the side edge over here. So in this case, it actually doesn't satisfy Euler's formula anymore because you have one face plus 0 vertices minus one edge, so it actually equals 0, not 2. So that leads us into something interesting. So if a 3D shape has a hole in it, like a torus, then instead of equaling 2 here, it's going to equal 0. So this basically the thing you do where you like add up the number of faces and vertices and subtract the numbers of edges, that's called Euler's characteristic. And different types of shapes have different numbers for that. So like you saw polyhedron, for polyhedron, this will be 2, but for shapes that have a hole in it, this will be 0. And for shapes that have even more types of holes or different topologies, they will have different numbers for that. What other shapes have one hole? Well, we will take a look. It could be a square with a hole. So like this one, I don't know how to pronounce this guy's name. Simon Lullier.
Yeah.
Okay, so this is like a square donut. This guy discovered that it's like if a polyhedron has like one hole, then the Euler's characteristic of it will be 0. So how many faces does this shape have? It might take you a moment to count. This is a more challenging counting problem. Okay, I see a lot of 12s and a lot of 16s. Let's count it together. So we have one face up here, another face here, a face on the very bottom, and a face on the left. So we have 4 of those like outside edges. So far we have 4. And next we have those 4 ones on the inside. So that's another 4. And then you have these 4 trapezoidal faces on the side, which is another 4. And then you have those another 4 faces on the side, but it's on like the other side of the shape. So you have another 4. So in total, you will have 16 faces. Okay, so how many vertices does this have? Looks like people are saying 16 vertices. So yes, there are 16 vertices because you have 1, 2, 3, 4 on this side, and then 4 on the other side, and then you've got the 4 little ones in the middle and the 4 little ones on the other side. So there will be 16 vertices. And how many edges does this have? So we have some people saying there are 16 edges and some people saying there are 32 edges. So let's see where the edges come from. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. We have 32 edges. I think some of you just forgot like a couple of the edges on like the side or something. So there are 32 edges on this shape. So obviously this doesn't satisfy Euler's formula, but it does, if you add up the faces, vertices, and subtract the edges, it does satisfy the Euler characteristic for a shape that has a hole in it. So now you see how different shapes that have different numbers of holes in it will have different values for this. Okay, so, oh gosh, don't look at that. Okay, we are going to pretend like you didn't see it. Okay. So, yes, it does look a little bit like Shrek. Okay, so far we talked about if a shape has 0 holes and if a shape has 1 hole. But what if a shape has like more than that number of holes? Like what if it has 2 holes or 3 holes or something? So in that case, we can actually write an even more general statement. You can actually calculate the Euler's characteristic of a shape based on how many holes it has. So if the number of holes in it is called n, so like for example, it has 2 holes, 3 holes, blah, 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 then the formula would be f plus v minus e equals 2 minus 2n. So for example, if a shape had 0 holes, then this term would just be gone. So that's why it equals 2. If a shape has 1 hole, then this part would be 2 minus 2, which would just be 0. So what would this value be in this green blob thing here? So what would that equal? So n would equal 2 in this case. So f plus v minus e would equal so it would equal -2. It sounds weird, but remember, this is Euler's characteristic. This is just a number. So it doesn't mean that this has -2 holes. It just means that the Euler's characteristic of the shape is -2. And this is because for n equals 2, this part up here would equal 2 minus 2 times 2, which is just 2 minus 4. So that would be -2. So this shape actually has a negative Euler's characteristic. So let's see if I, okay, let me find, if a shape has 7 holes, what would be the Euler's characteristic? Yeah, it would be -12 because 2 minus 2 times 7 is 2 minus 14. So that'd be -12. So the more holes you have, the more negative this characteristic is. So here's another shape that you've probably seen before. So what would Euler's characteristic be in this shape? Yeah, so this is a pretzel. It has 1, 2, 3 holes, which means that n equals 3. And for n equals 3, then the characteristic would be 2 minus 2n. So 2 minus 6. So that would be -4. So f plus v minus e equals -4 in this case. For a cup shape. I'm not sure about a cup, but a cup wouldn't really have any holes because if you think about it, it's like a cup, but the hole doesn't go through. It's just a shape. So I think a cup would probably have, I would guess that a cup has an Euler's characteristic of 2 because it doesn't technically have any holes. Okay, so this is a bit of a side note, but these are the Platonic solids. So they're they're kind of special because all of their faces are identical and they're all regular polyhedron. So for example, in a tetrahedron, all the shapes, all the faces are equilateral triangles. In a cube, all the faces are squares. In an octahedron, all the faces are also equilateral triangles. In a dodecahedron, they're all regular pentagons. And in an isocahedron, they're all also triangles. So those are the Platonic solids. And also all the faces on these meet at the same angle. So you notice how like all of these shapes are roughly spherical, and that's because all the shapes meet at this, all the faces meet at the same angle. And I think somebody mentioned that there are dodecahedron like shaped Rubik's cubes or something. So like, how many of these are like actual like Rubik's cubes? Like obviously a cube is like a Rubik's cube. And I think there's like triangle Rubik's cubes. And then somebody said there are dodecahedron Rubik's cubes. Are there like octahedron Rubik's cubes or isocahedron Rubik's cubes or something? Or no? Probably.
No, there's not.
There's not. Okay. Well, they need to start manufacturing these.
I
because-
googled it. There is.
Wait, there are octahedron and isocahedron?
Yeah, I think there's an I something that name.
I don't think there's an isocahedron, but octahedron.
No, I think there is.
Well, there is a isocahedron. I just Google it. Google it and maybe you'll find it.
So all of them.
I think
Yeah.
it's octahedron.
Google's not even accurate though. So you could easily make an octahedron cube and say it's a cube, but it doesn't like solve like.
Well, octahedrons have
You
triangle
couldn't even
faces.
solve that. How would you solve that?
I don't know. Maybe they do have it. I don't know if they actually work. though.
Well, pieces.
How do you turn triangles on a cube?
I think you turn them like this. So like you turn the top, and then you can
Yeah.
turn the faces or something. I've seen
Yeah.
one. It's just a little weird. It's different than a cube. But right now it sounds like all of these are actually real Rubik's cubes. So that's fun. Okay, let's do a little bit of just normal practice with normal Euler's formula, no holes, just with these Platonic solids. So how many edges would be in a tetrahedron? You might be able to just visualize it. And if you can, then you can do that too. Yes, there are 6 edges in a regular tetrahedron. So how many vertices would be in a cube? Or it's also known as a hexahedron, which I find very interesting. Like we should all start calling cubes hexahedrons from now on, and everybody will look at us confused. Hexahedron.
Kindergartners would have pain.
Yeah. So yes, there are 8 vertices in a hexahedron. How many faces are in an octahedron? Yes, there are 8 faces in an octahedron. That's why it's called an octahedron. How many edges on a dodecahedron? Now it's a little bit harder to visualize because, I mean, I don't think everyone has a picture of the dodecahedron in their mind. But yeah, there are 30 edges in a dodecahedron. And finally, how many vertices are there in an isocahedron? Yes, there are 12 vertices, and I might have forgotten to mention this, but I mean, you can probably see it now, but a tetrahedron has 4 faces, a cube has 6 faces, octahedrons have 8 faces, dodecahedrons have 12 faces, and you can sort of tell because the name, deca means 10, and then do kind of means 2, so it's 12, 10 plus 2 is 12. And then isocahedrons have 20 faces, and I'm guessing like isoca or something is like a prefix that like means 20, something like that. Okay, so now we are going to do something a little hands-on. So we're going to make an origami cube balloon thing. So if you, it's okay. I'll do my best.
How
to
many
try to help
pieces
you.
of paper?
Just
How
one.
many pieces of paper?
Just one.
Okay.
Preferably a piece of square paper. If you don't have a piece of square paper, I can show you how to make it a square.
If you can't do it, I guess you'll just have to watch the videos for now.
You should still try to follow along though. Maybe you'll,
Whoever makes the most perfect looking one, I'm gonna give just 2 points to.
you should at least attempt it.
You should at least attempt.
You don't have to have construction. I'm just using scratch paper. You can look at what's on my paper. It's like numbers and stuff. Yeah, I don't have like construction paper either, so it's all good.
If you want to make it later, we will post the slides, which will have this video on there. So like, you can make it later.
Yeah.
We'll wait for everybody to get paper. Amy, I'm pretty sure Yolanda made it with the AP seminar rubric.
Yeah.
It's like therapeutic getting rid of it,
Yeah. I mean, she put it to good use.
Yes. Oh yeah, it's not a paper balloon. It's like a paper ball-ish, except we're gonna make it into a cube
Yeah.
with one extra step.
I mean, I guess it's a balloon because you do have to like it's flat at first and then you blow into it and it suddenly inflates, which I thought was really cool. No, it will not. It won't like blow up as in explode. It'll like blow up as in like you blow in it and it inflates.
Yeah, for origami, if you like make each fold like as precise and like sharp as possible, it'll turn out really good.
Okay. If you guys only have copy paper, to make a square paper, I guess you could use a ruler and cut it into a square, or you could do something. I mean, I think measuring a square shape would be the easiest way to go. We just need one piece of paper. But there's also a way to make a square piece of paper where you like fold it like this so that the edges like line up.
And then cut off the remaining piece.
Yeah. So I'm just going to do that way because I don't have scissors. Well, I do, but I don't have a ruler.
Amy, do you want to show the video first? Because
Yeah, we will show the video first.
so you guys don't follow along right now. Just get a general idea of how to do it.
Yeah. This goes far too fast for you to just follow along. So just watch first just to get a little bit of an idea. So square piece of paper.
If it's like laggy for you, it's like pretty laggy for me. Here's the YouTube like video link.
It's really, really light.
So you can like watch it on your own. and then come back in like 5 minutes, you know?
There is one step that is confusing, but I think he already went past that step. So
Or no, you're just watching the video right now.
yeah, you're just watching it. I'm just trying to make a square paper. That's why you might hear folding noises in my background. You don't need scissors when folding. It's just you might need scissors if you want a square piece of paper. So if you don't have scissors,
You can always just like fold it and tear it, you know?
yeah,
That's what I usually do.
yeah, that's what I did.
You only need one sheet of paper.
Yeah, just one sheet. Unless if you mess up, but yeah. And then you blow it. Okay. Is everyone else done watching, or do you want like a couple more minutes? Okay, I'll give you a few more minutes. Yeah, YouTube videos always make it look so easy. But it honestly isn't too hard. There's just like a couple of steps that might be a little confusing. Okay, do you still need more time? If not, then I will. Okay, I will get started then. Oh, this is not what I was wanting. Okay, so the first step, the first step was to get a, oh my gosh, why does it do that? Okay, so the first step was to get a piece of paper, a square piece of paper, and then you fold it in half diagonally, and you make a sharp crease. And then once you do that, you unfold it, and then you fold it in half diagonally the other way. So I'm doing that. Okay. And then you can unfold it afterwards. And once you make the second diagonal fold, then what you're going to do is unfold it, and you're going to fold it in half. So just like a normal half horizontal fold. And then you unfold it. That's okay. We're walking through it right now together. So then you unfold it, and now we do something weird. So this is probably the weirdest step. So what you do is, so you kind of see this horizontal crease. So you kind of do this and you push it in like this. And you see what I'm doing with this? So it's kind of, these two edges here are coming in towards the middle, while these top corners are staying outside. So you do that. And then what you do is like you squish it down. That's basically what he did. It's just, yeah. So once again, if you need to look at it, so you kind of push these middle edges in while keeping these edges at the corner. So, and then once you have them like this, you push it down. So another time, so you have it like this. So you bring this, the middle of this edge together by using this crease to help you with that. And so this one will fold this way and this one folds this way. And so you bring them together and make sure that you keep these corners out here. And then once you have that, you sort of squish it down. This is probably the hardest step in my opinion. Does anyone need to see it again? Yes. Okay. So you have it like this. So you see these ones are going to fold up like this. So try to get it into this kind of, you see this shape here, and you bring these edges together. So it's sort of like this. So this crease is going to look this way, and you're going to squeeze it together. Do make sure that you're not just folding it in half again. What should be happening is that these two are coming together, and while these up here are staying apart. And then once you have that, you can squish it down. Do you need to see it again? If not, then I will move on. Is it just like not actually? Oh, okay, let's see. So yeah, that step is like the hardest step. I'll show it one more time. So you take this like paper, right? And then you sort of like want to bring these two together, but you don't want to just like fold the paper in half, because so you bring these together while pushing these parts apart, and it should like fit into the crease. It's okay if you can't do it. You can look at the video again later if you'd like. If you have that step mastered though, then the next step would be to fold like the corner to the top. So like over here, you would bring this up. So you bring this one up and you do the same for the other side. And then once you have these folded up, you flip it around and just do the same for these two. So you bring these up as well. So then you'll end up having this. And you keep it
I
together like
finished.
this. Oh, you did? Oh,
Yeah,
wow.
yeah. If you're blowing it, it just like blows up. Actually, what I mean.
Oh, okay. Yeah, it's good to do it slowly.
I'm done too.
Oh, okay. You should show us if you're done.
Nice, Colin.
Hashtag finished, gang.
Okay.
It's kind of ripping though. It's kind of fragile, especially with the saliva.
Yeah, it's a little delicate. If you're still trying to
You don't
follow
have
along,
to be that gross, bro.
if you're still trying to follow along, the next step would be to fold the edge like this across. And then you do it for both sides.
It looks cool.
Yes, it is pretty cool in my opinion once you get it.
It does.
It's just that one step is a little bit hard.
No, I think that was pretty easy, honestly.
It probably
I
depends.
think the step. I think the step that confuses everyone will be the one right now.
Yeah.
Oh,
This is the step that was hard for me. It's like no one will understand unless you watch it like 3 times.
I used to do origami a lot, so honestly, the entire thing was kind of easy.
yeah.
Oh,
Once you do
insane.
origami more,
I did
it's easier.
I did origami so much in COVID when we had to be in quarantine, like from 4th to 5th grade.
I did it when I was in like 3rd grade, 4th grade.
The best one I made was an Origami Spider.
Oops, dang it. The video moved forward. And then after that, I'll go through this a little bit quickly. So after that, you fold this up. That's okay. I think if you do origami more, you'll get better at it. So it's sort of like once you get used to the types of folds you make, then right now I'm on this step where you fold it upwards a little. And then what you do is you kind of open this flap with a pencil. I don't have a pencil. I'll use a pen. You open it with like a pen or pencil, and then you stick this inside of it. And this sort of helps to lock the cube in place. Because I don't think it's working for me. So give me one moment. There we go. So I'm basically stuffing this flap inside.
Watch the video on your laptop. It's way more easier.
Yeah, I would recommend if you're having a hard time right now, if you watch it later on your own time, that would help. I'm trying to finish my cube. Okay. And then you blow it. I hope this will work. Hey, it works. Okay. It's a little bit weird though. This one didn't inflate fully. There we go. It's an origami cube. And then since we kind of wanted a cube, I guess you could leave it like this, but I would add like a crease, if you can, to the edge. That way it looks more like a cube. But this is pretty good as it is. Okay, we also have steps here, like one by one, but these steps, I don't know if all of them are correct or not, because there's something at the end that got a little bit messed up.
On the poke thing, I made the hole too big, so it's like really weak.
Yeah, I have a pretty big hole.
I poked
as
it
well.
way too. I poked it way too much.
Oh, my
Like I
hole's
couldn't
this
blow
big.
into it. I
Look at
couldn't
mine.
blow into it, so I just. Where is
Now
it?
it's-
I
now
can't
it's-
see it.
I'm guessing it's just between me and Sai to whoever gets the 2 points. Or maybe share it. Depends on how you look at
I'll
it.
give you both 2 points.
Yay.
Yay! Let's go. We got 2
GG.
points.
I sort of ripped mine right there with the hole, but other than
no.
that, I think it looks pretty
I
good.
think Colin's in the first place for points.
Okay, I'll tell you guys the point rankings right now. Let's see. Let me add Colin's 2 points and then see.
Did I get 2 points?
Yeah.
Let's go.
Okay. So in class 1, wait, hold on. I need to ask Amy something. Okay, so this is like kind of
Tentative.
yeah, I don't
Definitely
know if
not
it's, like,
updated yet.
completely true. I did update it for today, but like I'm not sure if this is completely right. But so far, our number 1 in class 1 is, I think, Colin. Yeah, Colin
I
in
knew it.
first place, and then second place is Sai Shreyas. I think you just go by Sai. I'm not sure. At your second, and then third place is Akshat, I think. I don't know if I'm saying that right either. And then I'll tell you until fourth.
It's
Fourth-
Akshatha, I think.
No, there's 2 people. With
Oh. Oh, okay.
And then the 4th person is Aditya. I don't know if you go by Adi or like I'm confused on
You
your
go by Adi as well, Aditya.
I'm not sure exactly what's happening there, but yeah, you're in 4th place. Okay, so then class 2. This might change after we update today's points.
Yeah, because it's currently not updated.
Yeah, but this is as of yesterday. As of yesterday, 1st place is Advika, and then 2nd place, Leon. 3rd place is
Wait,
Brian.
I'm second place in what?
You're 2nd place so far in the points.
Oh, how far am I from first?
Just 2 points away.
Who's in first?
Advika.
Advika. I don't know if I'm saying everybody's names right. Wait, is it Advika or Advika?
Go.
Wait, what?
Like, I mean, both ways are fine, I guess.
Okay, do you have a preference?
You should call her avocado.
No.
Avocado is her nickname.
Can we call you avocado?
Her opinion doesn't matter. Totally.
Sanvi likes being called spinach.
No, I don't.
Spinach
Spinach.
avocado.
I was never named Spinach. Advika is called avocado by her whole class, so that's an established nickname.
Okay.
Class is evil.
Anyways, so our 1st place is avocado. 2nd place is Leon. 3rd place is Brian, I think. 4th place is 2 4th places ties. So the tie is between Addie and Sriram, I think. Yeah. But you guys, like, that'll probably change for you guys.
But why are there 2 leaderboards? Oh,
Yeah,
this
two
is class
classes.
2 and class 1 combined.
Yeah, today we combined them because we didn't have enough teachers. So some days they're combined, some days they're separate.
All right.
Yeah, I realized there was not one teacher.
Addie, you are like tied for 4th place, but it's like right, like 4th and 3rd are really close. Yeah, there's actually
Place Brian.
huh? You are I'm not exactly sure, but like since there's only 2 days worth of points for class 2, everything's really close. So like we kind of have to tell you again tomorrow.
Yeah, although the points will like reset after the 1st week so that you get another chance.
Yeah, so if you like fell behind, then you always have the chance to catch up. Oh, you're not gonna be here? Okay, you can watch the recordings, but it might like take a toll on your points, you know. So
What grades are class 2?
class 2 is just 8th grade, and then class 1, the O copies, you guys are 5th through 7th grade. Oh, okay. If you guys aren't gonna be here, yeah, you guys will just have to lose a couple of points. Well, not lose, but you know, like other people will be gaining points while you can't. But you always have a chance next week. So yeah, it's 11:27. If you are done, I will not be giving out 1,000,000 points, I promise. Class 1 leaderboard, I can say it again. Class 1 1st place